Welcome to the video on foundation design. In this video we will learn how to analyze and design the foundation. We can see the problem statement as given in this problem. This is the plan view of the foundation which we are going to design. Now the columns are naming as extreme left bottom side is given as column 1 C1, and as we move upward C2, C3, C4 and C5 and so on up to 16. And this is the safe bearing capacity 300 kilonewton per meter square, allowable settlement 1 centimeter. Subgrade modulus is given by SBC upon allowable settlement. On calculating we will get subgrade modulus. Column material M40 HYSD 500 and column strip width is 0.25 L1 or L2, whichever is less. Here L1 is the length of the building along x direction and L2 is the length of the building along y direction. Column strip width we will get on calculating 4.5 meter, but in this case we will take it as 4 meter. And these are the load which we get from the previous tall building design and analysis results in the video which we have performed in ETABS software. These are the problem statement. Now open the safe software, go to file menu and open new model. In the new model initialization dialog box, as we can see, design code should be IS 456-2000 and units should be metric unit. Click on OK. Then go to design preferences, click on modify / show option, minimum cover slabs, and then clear cover at top and bottom should be 50 mm as per the IS code, and preferred bar size take as 22. Now click on OK. In the initial model click on grid only. Now as we have already specified that the direction in x and y direction of our building is 18 meter, therefore we will require 19 grid lines both in x as well as in y direction, having grid spacing in x and y direction as 1 meter. Click on OK. This is the plan view for the foundation which we are going to design. Now we will define materials. Go to define menu and select materials. Click on add new material, and we are defining HYSD 500. Material type for HYSD 500 should be a rebar, and the weight per unit volume will be taken as 77 kilonewton per meter cube. Modulus of elasticity 200,000. And the minimum yield stress should be taken as 500 Newton per mm square. Minimum tensile stress should be taken as 545 Newton per mm square. Click on OK. Again click on add new material and material name as M40. Material type for M40 should be as concrete. Weight per unit volume will be taken as 25 kilonewton per meter cube. Modulus of elasticity for M40 should be taken as 316 to 2.7. And the coefficient of thermal expansion 0.000055. Concrete cube compressive strength will be, as the name suggested, M40 Newton per mm square. Click on OK. As we have defined the materials, click on OK. Now we will define slab property. Go to define menu, click on slab properties, add new property and give a name as mat footing. Slab material as M40 and we will take thickness as 800 mm. Type as mat. Click on OK. Again click on OK. Now we will define column properties. Click on define menu and then select column properties. Click on add new property. Give a column name as 500 by 500. Material should be as M40. Click on OK. Again click on add new property to define the second type of column and the given name as 600 by 600. We will select material as M40 grade. In this video we have defined two types of column, 500 by 500 and 600 by 600 dimensions, because we are using only two types of column in this building. As we have discussed earlier in this part, these extreme outermost columns have dimension 500 by 500, but the inner in these four inner columns have the dimension 600 by 600 mm. Click on OK to exit the window. Again click on OK. Now we will define soil subgrade property. Click on define menu and then select soil subgrade properties. Click on add new property, or you can modify the soil one. Click on modify. Now soil subgrade modulus, as we have calculated earlier, which comes out to be 3 into 10 power 4 kilonewton per meter cube. Click on OK. Again click on OK. Now we have defined all the materials. Now we will draw these. Go to draw and click on draw slab / areas. Make sure that the property should be mat footing as we have defined earlier. Click on any point and then move it to the extreme point. Again click. And then close the square box. Close this window and press escape button to exit the function. Now we will provide 2 meter offset, because foundation, this is the This area is same as the building plan view, but foundation have more area as compared to the building plan view area. Therefore, select the footing area, and you can confirm at the left bottom corner one area 4 edge is selected. Click on edit menu and then select edit areas, select expand / shrink areas and provide 200 mm offset value. Click on OK. We have successfully provided offset of 2 meter about all the sides. Now we will draw columns. As you can see, in this building there are two types of columns having the dimensions 500 by 500 and 600 by 600. The outer columns having the dimensions 500 by 500, whereas the four inner columns having the dimensions 600 by 600. Go to draw menu and select draw columns. Property below should be as none and the property above select as 500 by 500. Height below 0 meter and height above we will take as 2 meter. Now provide the columns as per the required locations. Now select property type as 600 by 600 and design the columns as per the required location. Close the draw column window dialog box and press escape button. Now we will design strips. Go to draw menu and select draw design strips, and as we have calculated the design strip width is 4 meter. .5 meter in our case, but we are taking it as 4 meter. I have added it as 4 meter. Make sure the design strip should pass through the center of the column. Just click on the center of the line and then click on the another point and press right click just outside the window. On the X direction named as strip layer as A, now convert it into as strip layer as B and draw the strip layers in the along Y direction. Press escape button to exit the function. In the same manner we can define all the strips. Make sure strips should pass through the center of the column. Just press escape button. As you can see, we have successfully designed strip A layer and strip B layer. Close this window and press escape button. There is an option named as set display option. Click on this button and select all the options in the design strip object. Click on OK. As here you can see design strip layer is shown. Again click on set display option and untick all these options. Click on OK to exit the function. Now select column center to assign the load. You can see on the bottom left corner to confirm that whether the column point is selected, column center is selected or not. Go to assign menu and go to load data and select as point load. As we already discussed that the dead load and live load for the columns is given here. For column 1, dead load is 1667.0876, and for rest of the columns dead load is given here and the live load is given here. First of all, we will assign the dead load and live load for the column having dimensions 500 by 500 to save our time, because we have two types of column. One type is 500 by 500 and another is 600 by 600. I am escaping this video because it will take some time. We have successfully assigned the load to the columns, dead load as well as live load. We can check dead load or live load just by right click on any column and go to load option. As here you can see dead load and live load is being assigned. Now go to assign menu, go to define menu and go to load patterns in order to check whether the dead load or live load is here or not, defined or not. Click on OK. Again go to define menu and click on load cases. Dead load is selected as linear static load case type. Similarly live as linear static, which is correct. Click on OK. Again go to define menu and go to load combination. There is no load combinations is defined here. Click to add new combo and select dead loads as 1.5 meter scale factor. And design selection should be as ultimate strength. Click on this, select as OK. Again click on add new. Dead load as well as live load. Design selection should be service normal, service initial, service long term. Click on OK. Again click on OK. Now we will define the soil property. Go to assign menu and go to support data. First select the soil area. Now go to assign menu and select as support data. Click on soil properties. Click on modify show property and then subgrade modulus should be 3e plus 0.4 kN per meter cube. Click on OK. Again click on OK. As here you can see soil property is being assigned. Now we will assign rebar material for the footing. Just right click on the footing area and go to design. Select rebar material as HYSD 500. Click on OK. Again click on OK. Similarly we will assign rebar material for the strips. Select rebar material as HYSD 500. Click on OK. Again click on OK. Select another strip. In this manner we will assign HYSD 500 as rebar material for all the strips. We have defined rebar material for all the design strips. We can check By just right click on any strip and head in the design, you can see rebar metal HYSD 500 is being assigned. Now we will run our model. Go to run and just click on run analysis. Save the file if you have not saved yet. Analysis is being completed, and here you can see the displacements is shown in the given figure. We can start animation to see the displacement. It is not showing here because we have selected it as in 2D view. Click on 3D view, and in the 3D view start animation. It is showing too much displacement, but actually displacement is very low. Stop animation and click as 2D view in the XY direction. Now go to run menu and click on run analysis and design. Run analysis and design is being completed. We will check design punching shear. Go to display menu and show punching shear design. Here you can see that in some of the columns value exceeded by value is greater than 1. It means that these columns will fail. Therefore we have to increase the slab thickness. First unlock the model, click on OK, and then go to define menu, go to slab properties and click on modify / show property and provide thickness as 1000 mm. Click on OK, again click on OK, and then go to run menu and click on run analysis and design option. Go to display menu and click on show punching shear design. Values greater than 1. Now we will go again for increasing the slab thickness. Therefore first unlock the model and then go to define menu, click on slab properties, click on modify / show property, provide the thickness of 1200 mm. Go to display menu to check again the design punching shear. Now after redefining the slab thickness and after analyze and design, all the members are passed because the shear punching design ratio is less than 1. We have successfully designed our foundation. Now go to 3D view and select set display option, click on extrude view and click on OK to see the 3D view of the columns. As here you can see This is the 3D view of the foundation design. Now click on XY and untick X2D view option. Click on OK. Go to display menu and go to show strip forces. In this tab you can check the moment, shear force, axial force, torsion, etc. along layer A, layer B, or along both layer and layer B. Click on apply. As here you can see moment is shown along strip A. Click on along layer B and apply. Here you can see the moment along layer B is shown in the figure. Similarly, we can check shear force both along layer A and layer B. Click on close button. Now go to display menu and select show slab forces and stresses. In this dialog box you can obtain the resultant forces, stress, mid, surface, etc. and for different load combinations as we have already defined. Click on OK, apply, click on apply and then close. Go to display menu and go to slab design option. Click on impose minimum reinforcing and apply. Here you can see the reinforcement along strip A is shown in the figure. Go to again display menu and show slab design option. Click on layer B and apply. Close this window. Now go to display menu again and show crack width option. Just click on it and click on apply. You can see the cracks developed in the slabs are shown in this option on the top layer. We can check also for different types of load as per the live load. Click on apply. Now we will go to run menu and click on run detailing option. Just click on OK. This is the framing plan view of the slab after run detailing. Go to detailing option and click on drawing component views. Go to slab views and click on rebar table. Framing plan is shown in the figure. There is a problem in my software, and because of which the other options like as rebar table, rebar schedule, bill of quantity is not showing. You can see rebar table, rebar schedule, bill of quantity, etc. just by double click on any one of them. In my software it is not showing by just double click. I don't know why, but you can check it. Video on foundation design has been successfully completed. Thanks for watching.